Dear students, today we will discuss ionization constant and ionic product and the relation between ionization constant of acid and bases with ionic product. Okay, these 2 points we will discuss in this lecture. Firstly, we will discuss the ionic product of water. Okay, water gives H plus ions and OH minus ions. Okay, very small amount. Actually, water is a amphoteric solvent. Amphoteric means which can act as a base by giving the lone pair, and which can act as a acid by giving the H plus ions. That is nothing but it is a amphoteric solvent. Okay, if you see the water, it can accept the H plus ions. Okay, this lone pair gives to the H plus ions, that is, it is acts as a base. Okay, the lone pair giving bases also called as base. Okay, according to the Lewis acid base theory, lone pair giving basis is a base, and lone pair acceptor basis is the acid. Okay, this is a acid, this is an acid, and this is a acts as a base, which gives the lone pair to the H plus ions. Okay, and also water gives the H plus ions to the bases which accept it. Therefore, it also acts as a acid. Therefore, if a basis acts as base by giving lone pairs and acts as acid by giving the H plus, is a amphoteric in nature. Okay, now we have the H2O and H2O. One H2 acts as the base and other is acts as the acid. Okay, if this gives the H plus ions to this, this lone pair accepts the H plus ions from this. Therefore, it is converted into H3O plus. Okay, first plus OH minus. Okay, the H3O plus is produced by H2O and H plus. Okay, first law gives the H plus ions. Okay, if 10 H2O is there and 10 hydrogen is there, it gives the 10 H3O plus. Okay, it is nothing but the concentration of H plus. Okay, therefore concentration of H3O plus is nothing but the concentration of H plus. Number of H3O plus is produced by number of H plus ions. Therefore, concentration of H3O plus means the concentration of H plus ions. Okay, now by applying law of equilibrium, okay, according to the law of equilibrium, the concentration of right hand side upon concentration of this, concentration of produced ions upon our undissociated molecules. Okay, therefore equilibrium constant K is equal to H3O plus and OH minus upon, it is one and the same, H2 is the same, therefore we have to take in single H2O, okay, single H2O concentration. Now the H2 is a very weak electrolyte, very weak electrolyte, very small amount it produces the H plus ions and the OH minus. Okay, H2 is the weak electrolyte, and we have taken it in excess quantity also. Okay, we have taken it in this case excess quantity of H2O, and it produces very minute or less amount this H plus and the OH minus ions. Therefore, the quantity of these we have taken as a constant. Okay, reason for this, why we taken it is as a constant, because very large amount, large and excess amount of H2O we have taken, and very small amount it produces the ions. Okay, it very small amount it produces ions. Because of these two reasons, and if it is produced very small amount, then no, actually it affects the concentration of H2O because it is in large quantity. Therefore, these two reasons we consider as the H2O is in large excess quantity, therefore it is considered as a constant. Therefore, K into constant, we consider this as a small k, H3O plus OH minus upon the small k. Now small k will transfer other side, capital K into small k is equal to H3O plus OH minus. Okay, we have discussed already H3O plus concentration is nothing but the concentration of H plus ions. Okay, number of H3O plus will produce from the number of H plus ions. So if 10 H plus ions is there, it gives the 10 to this, then you obtain the 10 H3O plus. Therefore, the concentration of this will equal to the concentration of H3O plus. Therefore, we can replace H3O plus by the H plus. Okay, and this K into K plus we consider as the KW is equal to, instead of this, because the concentration of this is equal to H plus ions and OH minus ions is as it is. Okay, this term is called as the ionic product of water. Okay, therefore ionic product of water is defined as it is a product of molar concentration. Okay, this is all about the molar, related to the moles. Okay, molar concentration of H plus ion concentration and OH minus ion, that is hydroxy ions concentration. Okay, therefore ionic product is nothing but it is a product. Product means the multiplication. Product of H plus ions molar concentration of H plus ions and hydroxy minus ions molar concentration of OH minus ions, that is nothing but the product of, that is ionic product of water. Okay, now at 25 degrees Celsius, okay, the experiment carried out at 25 degrees Celsius, and the concentration of H plus ions in water is found by 1 plus 10 raised to minus 7 mole per liter. Okay, therefore if water gives the H plus ions, this concentration of this, then it is also the gives the same amount of OH minus ions. Therefore the concentration of OH minus ions is also for 1 mole is equal to mole per liter. Okay, therefore ionic product of water Kw for 1 molar we have taken H2O at 25 degrees Celsius is equal to H plus ions concentration into OH minus 5. Okay, experimentally we found these values by putting these values in this 1 into 10 raised to minus 7 mole per liter into 1 into 10 raised to minus 7 mole per liter. Okay, therefore this into this is equal to 1 into minus 7, okay, this by the rule 10 raised to minus 14, okay, we summation this minus 7 and this minus 7, therefore mole into mole, therefore mole square, and liter minus and liter minus is equal to liter minus 2 square. Okay, therefore ionic product of water at 25 degree Celsius temperature experimentally found is equal to 1 into 10 raised to minus 40 mole square liter raised to minus 2. Okay, this is the experimental value we have found. Therefore it means what? The H plus ions and OH minus ions actually concentration is by multiplying you obtain the ionic product. Now we have to find out the relation between ionization constant, that is Kb, Ka and Kb with ionic product of water. Okay, Ka is ionization constant of acid. Kb is a ionic product of ionic ionization constant of base. Okay, we have already find out this value, ionization constant acid and the ionization constant of base. Okay, we have to find out the relation between, what is the relation between ionization constant of acid and the ionization constant of base. Okay, now we have a base. NH3 is a base, and we have to find out the relation between the ionic product. Therefore this is the mix with the water. It gives, okay, in this case water acts as an acid. It gives the H plus ions to the NH3. Therefore by giving the H plus to the NH3 is converted by, NH3 is a lone pair, take the H plus ions, it is converted to NH4 plus and OH minus. Okay, remember that NH3 there is a lone pair is there, and H2O there is hydrogen is there. Okay, according to the Lewis acid, the lone pair, the basis which gives the lone pair, it is a base. Okay, it is having lone pair, give the lone pair to the and accept the H plus ions. Okay, it accept the H plus ions, therefore NH3 plus 1 hydrogen, therefore NH4, and OH minus, the base is remained, we have written there. Okay, therefore it gives the lone pair, accept the H plus ions, is converted to NH4 plus and OH minus ions. Okay, this is about NH3 is a base. Okay, now by applying law of equilibrium, okay, law of equilibrium is the concentration of ions upon concentration of the undissociated ions. Okay, therefore it is a base, therefore for the base Kb we have taken the ions concentration of NH4 plus the concentration of OH minus upon the NH3. Okay, we have not taken the H2O because H2 is we have seen the how to find out the Kb in the previous lecture. Okay, you can see this lecture how we find the Kb. Okay, in Kb equation we have not used the S2. Okay, Kb equation we use these ions and the electrolyte. Okay, this is the for the Kb. Okay, then for acid. Okay, that acid NH4 plus acts as acid when we add the water, and water acts as the in this case base. Okay, therefore NH3 plus H3O plus. Okay, in this case you have the NH4 plus, 4 hydrogen is there, and water has the lone pair. Therefore those lone pair accept this hydrogen and it get neutralized. Okay, hydrogen will take this and this bond will take the NH4 ions. Okay, therefore this lone pair given to accept the hydrogen or given to this, therefore lone pair given species is the base and H plus given species is the acid. Okay, therefore NH4 acts as the acid and this water in this case acts as a base. Okay, in both case we have taken the electrolytes and addition of the water. Okay, thereby applying law of equilibrium. Okay, law of equilibrium is the ionic concentration upon the electrolyte concentration. Okay, therefore Ka, okay, Ka stands for the acid. Ka is equal to concentration of NH3 into concentration of H3O plus upon concentration of NH4 plus. Okay, this we have found in this case. Okay, therefore we have obtained the Ka values and we have obtained the Kb values. Therefore by multiplied by Ka into Kb, okay, we have taken the Ka is equal to concentration of NH3 into concentration of NH3 plus upon NH4 plus into concentration of NH4 plus concentration of OH minus. Okay, that is B. Kb value, okay, this value we have taken concentration of NH3. Okay, therefore the same terms we have cancelled, NH3 and NH3 cancel, therefore you obtain the H3O plus and OH minus. Okay, therefore H3O plus we have seen that H3O plus is nothing but the concentration of H plus ions. Therefore instead of this we have obtained H plus and OH minus ions. Okay, Ka into Kb. Okay, we have Kw, the value of Kw we have recently found is equal to concentration of H plus ions into concentration of OH minus ions. Okay, therefore Kw is nothing but this value. Therefore Ka into Kb is equal to Kw. Okay, that is the ionic product of water is nothing but the product of ionization constant of acid and the Kb. Okay, it is simply multiplication of Ka. Ka means the ionization constant of acid, Kb means the ionization constant of the base. Okay, by multiplication of these we will obtain the Kw values. Okay, Kw value is nothing but the ionic product of water. Okay, this is the relation between the ionic product of water and ionization constant of acids and base. Okay, now we have interested in pH scale. Okay, the pH scale is given by the Sorenson scientist, and he defined as pH is pH is negative log of molar concentration of H plus ions. Okay, and POH. Okay, POH is the negative log of molar concentration of hydroxy ions. Okay, OH minus ions. Okay, if suppose we have HCl 1 molar concentration, therefore if it is 1 molar concentration, pH value for HCl, okay, when you put the minus log and your concentration, therefore log 1 is the 0. Therefore pH for the very strong acid, pH for HCl is 0 when concentration is 1. And we have other substance that is a very strong basic substance. Okay, HCl is a strong acid, we have taken the HCl and its molar concentration is the, if you take the 1, and total ions of the H plus ions is dissociated, 1 molar dissociation you obtain. Therefore the concentration 1 molar of HCl give the 1 molar HCl ions. Therefore the 1 molar H plus ions, when you put in the our equation, that is the equation how you pH is equal to minus log to the base 10 molar concentration of H plus ions. Okay, now NaOH is there, and which is also 1 molar in quantity, and 1 molar quantity means it is having the, you found that when you have the ionic product of water, an ionic product of water is given by 1 into 10 raised to minus 14. Okay, therefore OH minus concentration into H plus concentration is equal to ionic product of water. In this case OH minus concentration is the 1 molar, therefore 1 molar solution of NaOH will produces 1 molar OH minus, because it is a strong electrolyte. Strong electrolyte is a tendency of to produces the almost all OH minuses. Okay, HCl produces almost 1 molar HCl, if you taken, it produces all the H plus ions. Okay, in this case NaOH, it produces 1 molar quantity produces all the OH minus ions. Okay, therefore OH is the 1 molar, and what is the concentration of H plus ions? Then the concentration of H plus ions are by using the K ionic product for the NaOH, concentration of H plus ions is 1 into 10 raised to minus 7 liter per mole. This is the concentration into 10 raised to 14, because 1 in this case when therefore H plus is 1 plus into 10 raised to minus 14 liter per mole. Therefore concentration of H plus ions is 1 into 10 raised to minus 14 liter per mole for NaOH. Therefore the pH is equal to minus log 1 into 10 raised to minus 14 is equal to value will be 0. Value will pH is equal to 14. Now for HCl it is a pH is equal to 0, and for the NaOH pH is the 14. Therefore there is a scale of pH is equal to 0 to 14. Okay, this is a scale. Okay, HCl to the NaOH, but minus pH is also present, and more than 14 pH value is also present. Okay, therefore this is one of the scale we have taken, but the more than this pH value also observed, and less than this pH value is also observed. Okay, now remember that the pH and plus POH is always 14 values. Remember that. And now we have Kw is equal to Kw. We know that the Kw is the H plus ions and OH minus ions, and Kw is equal to, if suppose P pKw is the value, okay, as like P or pH, okay, pH as like pH, this is P, that is potential of hydrogen. Potential of Kw is equal to minus log Kw, okay, as like this. Therefore pKw is equal to Kw, we have put these values, minus log plus H plus and plus, okay, that is minus log OH minus, okay, this is equal to minus H plus and minus H plus and, that is minus H plus and the, and this is minus H plus, this is nothing but the pH and this is nothing but the pH, okay. pKw is nothing but the pH and pH, and pKw, when you put the values, pKw will be 14, therefore pH plus pOH is nothing but the 14, okay. As like ionization constant Ka and the Kb, it is also converted into pKa, and it is also converted into pKb, okay. It is also minus log Ka, and as like minus log Kb, like that way we also define the pK and the pKb values, okay. This is all about the ionic product and the relation between ionization constant and the ionic product and the pH scale. I hope you all get these points. Thank you very much.